Okay, I'm going to explain the math review packet. Let's see. Okay. So, this is the April 9th review packet for geometry. So the first one, is find the area of a sector with a central angle of 180 degrees and a diameter of 5.6 centimeters. So the first tricky thing about this is that they give you the diameter, and we need to work with the radius, so you have to cut the diameter in half. So divide 5.6 by 2, and that'll give you 2.8, which is the radius. And then you can work with that. And they told you that the sector has a central angle of 180 degrees, so you're going to set up your proportion with 180 degrees on top and 360 degrees to represent the whole circle on the bottom. And then we're trying to find the area of the sector, so you have x, so you have 180 over 360 equals x over the whole area of the circle, which we can figure out now that we have the radius of 2.8. So the area of the whole circle is pi r squared, so pi times 2.8 squared. So then we have everything we need to cross multiply and figure out what the area of the sector is. So you have 180 over 360 degrees equals x over pi 2.8 squared. So you're going to cross multiply and multiply 180 times pi times 2.8 squared. 2.8 squared is 7.84. So you end up with 180 times pi 7.84, which ends up being 1411.2, and that is equal to 360x. And then you just want to get x alone by dividing both sides by 360, so you end up with 3.92 centimeters squared times pi. And then for this one, you do want to put in your calculator 3.92 times pi, and that'll give you 12.3 centimeters squared. For the next one, you want to find the total area of that circular dartboard with radius 2. So you find that by doing pi r squared with 2 as the radius, so you do pi 2 squared, which is pi 4. So pi 4 represents the full dartboard, and they tell you that the probability of hitting red is 0.6. So you could set up a ratio where you have x being the red center of the dartboard, so x over the full dartboard's pi 4, equals 0.6 over 1, so that'll represent the probability of hitting the red circle 0.6 out of 1 times. So then you have that ratio, which I've written out near that problem. So you have x over pi 4 equals 0.6 over 1, and then you just cross multiply. So you're going to get 2.4 pi equals pi r squared. Then you're just dividing by pi, so then you get 2.4 equals r squared, and then you just take the square root of r squared and the square root of 2.4, and you get 1.549 equals the radius. For number 3, find the area of an equilateral triangle with radius 8 square root 3, so you have to draw on that radius and then make a 30, 60, 90 triangle with the radius being the hypotenuse, and we know the hypotenuse is 2s, so therefore 8 square root 3 equals 2s, so therefore s equals 4 root 3. And in this case, the side opposite the 30-degree angle is the apothem. So the apothem is 4 root 3. And we know that for a regular polygon, which an equilateral triangle is, we know that the area formula is half apothem times perimeter. So you could use that here. So you'd have half of 4 square root 3 times the perimeter. And the perimeter you could figure out because you can figure out that the bottom of that triangle that you made is s square root 3, and if s is 4 root 3, then 4 root 3 times root 3 is 4 times 3, which is 12. So half of the side length of the equilateral triangle is 12, so the full side length is 24. So the perimeter of the whole triangle is 12 times 3. Oh, sorry, not 12. 24 times 3. Sorry, because the full side is 24. So 24 times 3 gives you the perimeter, which is 72. 1 second, just be right back. Okay. So then you have the perimeter, so then you could do half 4 root 3 times 72, and that's going to give you 144 times root 3, which is the right answer. Okay, number 5 I think is a lot easier. It's just using the radius, which they gave you, 3.6, and putting it into pi r squared, so you get pi 3.6 squared, which is pi 12.96. So that's C. For 6, they want you to name a major arc. So a major arc is bigger than 180 degrees, so therefore it's going to be arc ADB. And you can figure out its degree measure by subtracting that 50 degree slice from 360. So the major arc is ADB and it's 310 degrees. This one's one of the harder ones, but it's what you did on your last test. Okay. Find the area of the regular polygon, round your answer to the nearest tenth. So you have to remember a lot of old school knowledge from the last test. So it's an octagon. If you count up the sides, there's 8 sides, so you could figure out the central angle measure by doing 360 degrees divided by the number of sides, so 360 degrees divided by 8, which gives you 45. And then for that triangle, you know, you always want to make a right triangle in the shape, so when you divide that bigger triangle in half, then you make that top angle 22.5, and then you have to use sine, cosine, or tangent to figure out what the apothem is, because they give you the hypotenuse. So I decided to use sine, because I figured out if you have that 90 degree angle and you have that top angle at 22.5, then you can figure out that bottom right hand corner angle is 67.5 if you subtract 22.5 and 90 from 180 degrees in a triangle. So then you can do sine 67.5 equals x, which is the apothem, over 13.07, which is the hypotenuse. So then you can find that the apothem is 12.07. And then to find the full area of the octagon, you could do half apothem times perimeter. So it'd be half 12.07 times 80, because you could figure out that the perimeter is 10 times the 8 sides, so the perimeter is 80. So just to get the area, you do half 12.07 times 80, and that gives you 483. 8 is a little bit easier. They just want you to name a minor arc and find its measure. So you're just looking for the arc that is less than 180 degrees. So here it's arc AB, and it's 115 degrees. You can get rid of C and D because they're over 180 degrees. You don't even have to really think about those ones. Number 9 is a regular hexagon, so that means it has 6 sides, and its perimeter is 150. They want you to find its area, so you could do the triangle strategy again. The central angle for a regular hexagon is always 60, because it's 360 divided by the number of sides. So 360 divided by 6, which gives you 60, and then you know, you always want to cut that triangle in half so you have a right triangle with a 90 degree angle. So the top angle of that new triangle is 30 degrees. And they tell you the perimeter. You can figure out the side length based on the perimeter, and that's what you have to work off of to start filling in this triangle. So you do 150 divided by the 6 sides, which gives you 25. Let me just check. I know I messed this one up initially. Let me double check. 150 divided by 6. Yeah, that's 25. And then that's the full bottom of that triangle. So you want to cut it in half to get just that part of the triangle. That's the bottom of the 30, 60, 90 triangle. So that part, that bottom of the 30, 60, 90 triangle is 12.5. And that's opposite the 30 degree angle, so that's S. And the apothem is opposite the 60 degree angle, so you know that the apothem is S root 3, since it's opposite the 60 degree angle, and you can insert S as 12.5, so then you get that the apothem is 12.5 root 3. And then they already gave you the perimeter, so then you just have everything you need to find the area of this hexagon. So it's half the apothem times the perimeter, so half 12.5 root 3, which is the apothem, times 150, which is the perimeter that they gave you. And that gives you 900, I just got 937.5 root 3.